The simplest possible way you can describe a perpetually persistent universe, the simplest possible one, uses the simplest three manifold called the Giesecke manifold, and you double cover it so you become orientable. That makes the smallest possible hyperbolic anchor in a system. So you've twisted your system via the hyperbolic figure 8 knot, leaving you with a rigid structure, a rigid universe of symmetry that continues to flow along the boundaries it just created over and over and over. This is the structural equation for the hyperbolic figure 8 knot. This is the symbol for the volume of the hyperbolic figure 8 knot. And this is I, the square root of -1, and this is the dilogarithm of 1 over the imaginary golden ratio, which is the third power of -1 instead of half power of -1, and a dilogarithm of, again, the imaginary golden ratio. And that structure comes also with its inverse at the same time, which is drop the I, get a real conjugate, so we change the negative sign to a positive sign, and now this structure gives us 4 pi squared, sphere doubled, divided by 288. A number that triggers you right away. Beautiful, beautiful, we have that because the symmetry group of the hyperbolic figure 8 knot is tetrahedral. And this is the full tetrahedral number. This is the total number of symmetries that tetrahedrons possess. Another reason this is fantastic is this is equivalent to this times this, which famously, this is the maximum density packing for sphere packing. Kepler discovered this a long time ago, or conjectured it. I think it was proven just recently in like 2003 or somewhere around there, so quite recently. Both of these two things are the same number, of course, but it turns out that there are two different lattice structures that possess this maximum density packing. You can have the face-centered cubic one, and you can have the hexagonal close packing one. Hexagonal base shapes or squares, okay? So face-centered cubic, hexagonal close packing, the two kinds of lattices that you can have that have maximal density, both exist as the projective real conjugate of the hyperbolic figure 8 knot. So both of these things represent the smallest distortion you can create in a vast void of infinite nothingness to then have a perpetual system. It's not an infinite perpetual system. It didn't infinitely affect everything outside it. It took a finite region and twisted it into this logical structure, okay? Both parts. There's another half to the story. This double covered sphere has other spheres outside it touching it. And you can fit exactly 12 spheres. 12 spheres can touch a central sphere. They're kissing it, they're all barely touching it. You can't fit any more spheres in the arrangement, okay? You can fit 12. This is a beautiful, fantastically famous connection to something in geometry here. The volume of the 24-dimensional unit hypersphere is equal to this entire structure, which is just 12 spheres. If you count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spheres. That's our 12 outer spheres, and they're divided in these ways. All the ways 5 things can factor, all the ways that 5 things can derange. This one's got a restriction. This derangement has a restriction from the factorials, and it's just putting together some of its own pieces, but alternatively. Okay, really beautiful symmetry, but both of these show up. Now, other than the one that completely falls apart, there's 5 kinds of spheres here. They're divided by different numbers. This one's 44. The derangements of 5 things is equal to 44. The factorial of 5 things is equal to 120. But 44, 35, another 2 spheres divided by 18, another 3 spheres divided by 32, 4 spheres divided by 8. So this structure gives us also a hierarchy, right? 44, 35, 18, 32, 8 is the power arrangement. That structure should bring the hair on the back of your neck up if you're a physicist. Those are the numbers. These are the modular numbers attached to the 5 Planck constants. Oh, I didn't even mention, they also represent the density of the Leech lattice. 2 things match up perfectly right there, introducing a perfect symmetry in lattice structures and hyperspheres. We have a structure with 12 spheres outside our double-covered projected sphere from this minimal structure here. And those 12 spheres have to be unitary and they have to surround the internal sphere. Then we knew, or we found out, that there was a certain structure here that had this famous actual arrangement that we needed. And we noticed that it had the same division arrangement as the Planck constants. So that suggests we can look into figuring out hyperbolic boundaries, because we know this is all a hypersphere connected together in a specific way. So we want to describe the hyperbolic boundaries of this one that connect compatibly to the rest of that structure, right? If all that's happened at the same time, well, let's make this guy's at the central story right now and say, how does he connect to all the other divisions that are happening? And then how does he connect, and how does he connect, and so on. We're looking for a hyperbolic definition. For any kind of hyperbolic definition, a boundary that's definitely hyperbolic, that matches this structure we've started with, right? So you can only take things, you can only build your hyperbolic equations for each of these different 5 boundaries out of hyperbolic things that are in the structure, which is a nice restriction. It was able to get 5 definitions for these 5 boundaries. We used the coincidence here that they have the right division structure for the modular boundaries of the Planck constants to put in the Planck constants. So we have a measured number for the Planck, let's see, Planck time. Okay, and we know it so well, but not too well, like 5 significant digits plus or minus something next to. But since we know the first 5 digits, we can use that information to restrict. Our hyperbolic equation has to get us to those 5 digits, at least that accurately. The rest of it is unknown, but we have to get that much. This was enough of a hint to decode what was going on. So we have this representation of our 12 outer spheres whose division structure matched the Planck constant division structure. So we use this. We know we're going to have these different ways of dividing, and we're just going to have a hyperbolic rotation and some other hyperbolic structure to it. That was enough for us to find this pattern of hyperbolic decomposition, which you see kind of extends the pattern we're building here. Anyway, with the claim that this is the hyperbolic definitions of how we're compatibly dividing all of these boundaries at the same time, we then get exact definitions for those actual boundaries. And that extends the digits we had for the Planck constants to as many as you want. It builds a universe that's dividing into the right number of pieces, the same way that the Planck constants divide things into pieces, right? And hyperbolically keeps those things as closed boundaries. All right, so this has given us ways to guess the actual definitions for the hyperbolic boundaries for the Planck constants. And then we use those boundaries to then see if we can fit together the information of all the constants of nature to find a pattern in them, to see further into them. Now, if you got the wrong definitions here, then you're not going to find the pattern, right? And it's not like you find them right away. You have to search really hard to find the best one. You have to make sure you've searched all of the space to make sure you find the best one. But we are now years down the line, and we have what we think is definitely the best set for the Planck constants. So the story we have so far is a hyperbolic figure-8 knot, which has its real conjugate, 4 pi squared over 288. Each of these pieces that make up the hyperbolic figure-8 knot, the dialogarithm of 1 over the imaginary golden ratio, that single piece breaks into a real and imaginary part itself. The real part is 4 pi over gamma of 5 squared. Gamma of 5 is 24. And the imaginary part is negative Giesking constant times I. Okay? The other part, it does the exact same thing. When we reverse the argument here, it's 4 pi squared over 4 pi over 24, or gamma 5 squared again, plus GGI times I. Okay, This gamma of 5 on the inside is being countered here with the derangements of 5 and the factorial of 5. All three of them, which are all married, of course, structurally, but they're all showing up as the central parameters of the limits in our structure here. The 5 is very central. It's a base 5 structure, and it's defining now the boundaries of the 5 bases. This is a beautiful, simple set if you understand what it's saying, but the nicest thing is we're only making we made 5 claims here for the definitions of our hyperbolic boundaries for the 5 different bases, okay? They give us full definitions or closed forms for the 5 Planck constants, and the 5 Planck constants then have 2 rules that partition them hyperbolically according to the hyperbolic figure-8 knot structure, and the constructive rule for how we put them together. 2 rules, one for taking it apart, one for putting them back together, and they all apply to the Planck constants. In fact, you can see in the rule itself, the fixed boundary on the right, the internal part, is defined always as the same set of boundaries, and those boundaries are the Planck mass over the Planck charge squared. This is an equation that applies directly to how the Planck boundaries are put together. And the equation below it, the hyperbolic partition equation, is an equation for how the Planck boundaries partition within the Planck mass gap. Beautiful, simple, short. And then, from there, all we have to do is look into the actual structure of this hyperbolic partition equation. It has 4 different roots, Cartesian roots, or you can define them in polar coordinates also and get Jr and Jθ. Okay, so these are polar transforms of the Cartesian 1, 2, J1, 2, 3, and 4. But J1, 2, and 3, 4 have these most amazing algebraic properties. I want to focus on them a little bit, so let's zoom in here. The product of these 4 roots, the roots that define the hyperbolic partition equation or structure, the way that we're hyperbolically dividing our Planck constants within that Planck mass boundary, okay? All 4 of those roots have a product of 2 pi. These are beautiful, beautiful geometric numbers. They are in 4 parts put together to make a circle. Another beautiful algebraic thing of their structure is that instead of multiplying them, if we add them, we get 0. If we take all those minuses, we get 0. If you square them first and then add them, you get negative 4 pi. What beautiful numbers. They have the most beautiful relationships ever. There's a whole bunch of other things here. We'll scroll through real slowly. J3 plus 4 divided by J1 plus J2 is equal to negative 1. J1 squared times J2 squared over 2 pi is equal to 2 pi divided by J3 squared times J4 squared. Fantastic symmetries all throughout. You can take the sum of every byproduct of the J's, J1 times 2, J1 times 3, J1 times 4, J2 times 3, J2 times 4, and J3 times 4. Add them all together, and you get 2 pi. A lot of beautiful geometric structure. Go ahead.
Did you mention how what the G, you showed the numbers, right?
Yep. Yep, the numbers are right here. And they come from this equation exactly. All of them are the solutions to this equation. So this equation has an x in it, so it applies any scale x you want to apply it to, but when you want it to be equal to this right-hand side specifically, then the x's only satisfy this. These are the only x's that do it. Okay, so these are the 4 solutions. I personally find this thrilling. The fact that we can be pairing in it all, right? Whether right or wrong, the fact that you're investing yourself in trying to make sense of the world. Try this model, try that model. What's wrong with it? What's the benefits of this one? The investigation itself is thrilling because the end result has the biggest payoff consciousness has waiting for it. The main goal here is to get invested in this way of thinking, because this way of thinking has the numbers back in it. Right? This is a story that logically gives us all the structure we've discovered so far. You could argue there's lots more to discover, and perhaps there is, but all the fundamental things we've been able to measure as essences of reality get captured by this one geometric structure, which means we can conceptually conceive it. We can parse it. We can get to know it better by investing more and more time in it. Okay, so perhaps for me, or anyone who's been grasping for a way to conceptually understand all the structural elements of physics, right? You go from completely vacant story to a story that has all that. It's a lot to wish for, but if you've had the courage to wish for that before, we have a story here that's building the simplest possible manifold. It has a double covered sphere as its real conjugate, and that's at the center of 12 then surrounding spheres, defined by the Leech lattice structure or the volume of the 24-dimensional hypersphere. It's all literally just hypersphere construction based off of the hyperbolic figure 8 knot. The two limiting lattice structures at the same time are being formed as the real conjugate when we form the hyperbolic figure 8 knot, right? That's beautiful insight and short and simple, but it's also very powerfully geometric. It gives us our best geometric lattices right from the get-go. Fantastic. Also, since this structure here, the 12 spheres surrounding all this, that are countering all the winding up we did here, that has to be countered on the outside 12 spheres, and it has to be exactly 12. If you're only going one layer, then since they all have division denominators here, they're dividing the sphere up in the number of pieces that are perfectly matched to the number of ways the Planck constants modulated are, so their modular power, same exact list. Or in chemistry, if you look, the periodic table of elements has 2 elements on the first row, and then 2 rows of 8, 2 rows of 18, and 2 rows of 32 in the periodic table. So it's connecting things there. The charge, temperature, and mass structure of reality being connected to form the different kind of allowed chemical arrangements. Okay, so the interest here now is once we have the simplest possible structure, the story for that structure, we then want to interpret how all the different connections between this division structure fit together. That's it, we just want to try to interpret. So we know now we have a system that has this many different kinds of spheres. It's got 12 total spheres, but a total of 1, 2, 3, 4, 5, 6 of them, and 5 of them are under balanced derangement. Well, we're assuming we're going from this set all the way to this set at the end. And this is the way we go into that set from this set, right? It takes 6 steps. All right, so if that's our structure, we can then invent 5 boundaries that are compatible with this division structure. And when we do, we get the 5 Planck constants. And those 5 Planck constants then can be interpreted literally as the limits or the boundary of the division base in each one of these different spheres. Okay? And since they're different sizes, different numbers, we're going to get asymmetric scaling structure. We're going to have a smallest base and then a bigger base and so on. They're going to be all different sizes from each other. This one, starting from here, this one is the biggest one, so it's going to be the smallest base. We've divided it into the smallest number of pieces, so the most number of pieces, the smallest pieces. With this story of the simplest projected universe that's balanced and closed, we can get a richer picture than this, of course, but you have that picture, I think, in your head. 12 kissing spheres, the central sphere is a double sphere, so really it's 14 total spheres. That's a simple structure for all of our vertices and connections to be defined on, and 5 definitions for the way we're compatibly dividing gives us 5 Planck constants. The Planck time, the Planck length, the Planck charge, the Planck temperature, and the Planck mass.
I mean, now an atom is almost like its own little universe within a greater atom.
Actually, at this point in the conversation, the thing we've been describing is just one helium atom. If it was just half of this, it'd be a hydrogen. If it was just a single Giesecke manifold, but it's double covered and now secured, keeps itself. It's the minimal possible structure that keeps itself. And that's this hyperbolic structure, and I believe that's the helium atom.
So you're saying a helium atom has all the same properties as, or the same parameters as the universe?
A helium atom, if you formed an helium atom, you've formed the simplest universe you can form, meaning perpetual structure that will keep itself. And it comes impregnated with all of those properties all by itself. And then you can take the helium atom, that simplest possible universe, and you can break it down to a hydrogen, and then it can fall apart. You can do all kinds of things, but you can also go just the right way to turn it into lithium, and then beryllium, boron, carbon, nitrogen, oxygen, freon, neon. You can keep going down the list by twisting things up the right way. You can twist along the mass boundary in the first 2 rows. You can twist along the temperature boundary in the bottom 2 rows, or the charge boundary in the middle 2 rows. Right? So these are available transforms of twisting. So this is a simple picture. 14 spheres, which I think you can hold in your head. There's 2 special ones in the middle, right? Double covered there. And then 12 on the outside. 5 boundaries to compatibly divide those outside spheres. And then we have 2 rules to fit those 5 boundaries together. They all have to be hyperbolically structured according to this equation, and they all have to fit together according to some geometric action on the exterior, on the outside, times or multiplied by some boundaries on the exterior. And these boundaries will always be defined by the dimensions of the constant we're talking about and interpreted by the Planck constants as their inputs. So if you have meters per second, you're going to have length per time. That means you have to have Planck length over Planck time. And that's going to be multiplied by 1 plus some other action on the inside, interior, and fixed set of fixed set of inversion boundaries that everything in this balance inverts about. And that's just equal to the Planck length, and so the Planck mass over the Planck charge squared. And we take the absolute value of it because we want the magnitude of that conic structure that we're building. All right, or that diversion structure.
Cool.
Okay, according to just these 2 rules and these 5 division structure rules, we can fit that whole picture together, this whole 14 sphere picture, to get every constant of nature. It's an absolutely simple and beautiful model. Now, if you can hold that in your head, you can investigate all the actual features, the division structure that leads to every single transform we call a constant of nature, or that involves each constant of nature. It's a fantastic leap forward that we're getting an option here for. We've been trying to come up with a story as humans that could make sense of what we actually see in reality. Now you've got the whole level of arguing over what we see, right? It could be in the politics where you're always making up lies and other people are always trying to fact check your lies, but you're always just arguing over what you're seeing. But then you can come up with some objective way, get out of that entirely, and start looking at the world objectively, finding things that aren't arguable, actual, real, measurable features, okay? A realness that you can pull out of the world. And when you get into that level of looking into the world, then there's mysteries that pop up that need explaining. The big mysteries, the speed of light, the gravitational constant, the electric constant, the magnetic constant. There's 288 measured constants, right? Now when Newton came along and discovered the ordered structure in reality that gives us calculus, he didn't have any of those measurements. None. We didn't know to a first significant digit what the speed of light was, right? Most people don't know today. They report it as 3 times 10 to the 8. It's actually 2.99 792,458. Don't even give the first digit right. Okay, those mysteries that are completely unknown beyond the fact that they are the guiding clues for what reality really is, now have a story that I think anyone taking it seriously can understand. It's a story that gives us a minimal perpetual universe, right? That minimal perpetual universe divides magically as our universe does. With all the same transforms and features, with all the same constant built-in actions. And that's, I don't know how to think of it more exciting. Why? Because consciousness, you'd say, might be the deepest root of what we are. We're many things, right? But we're conscious things too. And our consciousness is limited or capped by the accuracy in which we're able to look into the world and tell a story about what's really going on. When we tell it more accurately, we can make better predictions. When we can start building things that do things on purpose and do it right? The more accurate we get, the more we can do, the more empowered we are, the more access we actually have to that world. Before that, we were on a level more blind, and even more blind, right? We were looking into the world and telling a political story, and then believing and living in that political story, never measuring anything, never really looking into the world, right? Every curious young person, I think, tries to understand what the world is, right?
subconsciously, that is what we do. We're always making meaning of our experience.
Exactly. That's what consciousness has to do, right?
Right.
When consciousness is able to gain a story that can make meaning of the things that are actually the teeth of your existence, your power really, really, really will go up, right? Our power as a species will completely change. We'll be able to do orders of magnitude more things with more ease. I'm really excited to get there to the point where we can conceptually talk about the degrees of freedom that build chemistry, to see the actual structure that's responsible for the periodic table of elements, to watch exactly what has to happen to go from this chemical arrangement to this chemical arrangement, to see the steps, step by step, in evolution. Right? There's so many beautiful things you get to look into much more richly when you have a model that already cages and frames the logic for things that have to evolve under that system. Do you know what Newton did for the rest of his life after all of his fame was up and he had every option in front of him?
Was it trying to turn lead into gold?
Yeah, basically. He was very big and he was religious. He spent a lot of time on religious thoughts and readings and stuff and writings, but he also was very big into alchemy. He became convinced after discovering the structure of reality that gives us calculus, which we then leaned on to build all of our modern machines, okay? Once he discovered though and understood that structure, he was absolutely convinced that alchemy was possible, that it was possible to transform one form of matter to another form, okay? And all of them really, because he understood the world had to be built in a combinatorial way. He had peered into the logic of combinatorics, and that logic had to extend to actual real things. It had to apply to actual real things. He had found that it did. So he spent the rest of his life completely convinced and invested in alchemy. Now, it was way before the time. Why? Well, because even though he discovered that things had to be logically connected, he didn't have any of the measurements. He didn't have any of the scaling factors for this hyperbolic structure that actually is connected, right? None of them. And he even wrote, it's just too early to do this, right? There obviously has to be all of these other features of the world. We haven't measured them yet, and until we've measured them, we can't make sense of them. Okay, we're now at a point in time though, where we have the measurements, right? You might want better accuracy for some of the measurements, and we've all been wanting that. We've been trying to get as much as we could as scientists, right? But at this point in time, we're actually at a very impressive level of accuracy for all of these 288 constants. Some of them are almost 14 significant digits. That's like, seems to be the limit, right? But 10 to 14 significant digits is a lot of accuracy in a measurement number, right? If you try to imagine drawing a circle, using a string and everything to make a real accurate circle, okay? And then trying to actually just measure, as a human, with your hands, find some way to measure the actual diameter to circumference, and then divide it by diameter. Try to get your measurement of pi. Say, how many digits of pi do you actually get from your measurement, okay? It's very difficult to get more than 3. Without just knowing the number that you need ahead of time in line. Okay, so for CERN, for our best experiments in all the science labs in the world so far, to have come up with the precision we've got so far, that's what Newton was actually dreaming of. That's the missing information Newton didn't have. He knew there was an ordered structure, he knew it well, right? But he couldn't try to make sense of the ordered structure without the actual parameters that fit everything together, the constants of nature. Now, we get to do that. And we have come up with a simple way of interpreting every constant of nature as just part of the partition structure of the simplest possible persistent universe that could be formed, geometrically. The simplest thing that can close on itself and then be perpetual. That's it. Its division structure completely captures the actions of physics, which means we can import a model into our head now, into our consciousness, that sees the world from that lens, and therefore can see the actions that actually define chemistry and the levels of reality on the way up. We can comprehend things on the level that I know all of us desperately wanted when we first started going to college. Right? You desperately wanted to know, why is general relativity true? Why do black holes exist? Why do they have this weird effect with time? Right? Whenever you got exposed to these different things that we're claiming we've measured and seen in reality, the question was, well, why? I want to understand why. I don't want us to hold, there's another magical thing out there in the world. The quantum mechanics says this other magic thing happens. Okay, but I want to know why it's there. Because until you know why, you can't really do much with it. And it's not just that you want to be able to be greater in power, to have more things you can do from the comprehension. The comprehension changes the way you feel about reality. It changes the access you have, so it changes the way you feel. It makes you feel like more, right? It makes you feel more capable. It makes you feel more capable with more ease, which feels empowering, right? The concepts that we occupy give us certain access to the world, right? The vision that we have of the world, the way we each individually see it, is the way we can access it. And if we learn to see it this way now, we have access to all the mysteries of chemistry and physics. We can build machines that use the inner workings of the electron and the proton and the neutron, that understand why they fit together the way they do and are allowed to connect in the different ways that they do, and then does it on purpose. The way our machines, our computers today, build and do things for us over and over. It's going to be a very, very exciting time where we're at the threshold right now. We've just recently got to the point where we discovered we can describe the simplest possible persistent universe and map all of the actual constants of nature to it, right? Now, peering into all the different structures that mapped, all the revealed structure, will give us more and more clues, will allow us to build, and bring us all to an era where everyone can hopefully be invested. Instead of making up a story and doubling down to make sure that's reality, instead they could be using more directed and real objective ways to find the reality they're making sense of.
As a psychology major, excuse me, it reminds me of what Carl Jung said, that until we make the unconscious conscious, we will take everything that happens to us and call it fate. Mm-hmm. So almost like thinking of like what we know,
because it's incomprehensible.
Right, what we know so far, like as sort of consciousness, but it's just the tip of the iceberg. This is like going to reveal to us the subconscious that is actually has way more power and effect over our reality than we are aware of. Mm-hmm. Would that be a good way of thinking about it?
Yeah, it's a good way.
Okay.
I want to find other people who are passionately interested in the access to reality, this new way of seeing gives. Because you have to be passionately interested, because it's basically saying, here's a new language. You need to learn the language. You have to invest yourself to learn
but someone language. So what I hear you saying though is like, you're looking for someone who's open-minded to...
Open-minded is definitely a necessary trait, but I want actively engaged open-minded. So not just somebody who's willing to entertain whatever friend says here and this friend says there. I'll take on any idea. That's a kind of open-minded. I need actively engaged open-minded over the pursuit of making sense of the actual reality.
Scientist.
Yes. So somebody who is invested emotionally in finding the truth. Not somebody who is primarily invested in trying to impress others or prestige or power or that sort of thing. They want truth because they realize there's a level of truth way beyond the one I have. The one that makes sense of electrons, protons, and neutrons and all the stuff we're saying in physics and chemistry and biology.
So you're looking for someone who at their core believes that it can be understood.
Yeah, exactly. I would love to put together a summit of people whose primary qualification is that they are actively and have been actively under pursuit of the true story of what reality is. And they would like to get together and talk about this discovery of a model that simply cages or frames a universe, right? A universe we can actually wrap our mind around and investigate specifically. And all of that simple universe's individual traits give us the constants of nature. So this gives us a new alphabet. And I think if there was a group of people who were devoting their passionate energy, but also trained, because they've been doing this for a while, they've been actually looking into reality for all the details. So it means they're well informed. Yeah. Which means they can also be as excited by these things. If you've never really heard of the mass of the electron, or if you've never spent a single hour of your life fretting over why it has what its mass has, seeing how many things depend on that and thinking, wow, if it changed just ×2, look at all the changes that I know about. Think of the ones I don't even know about. The world wouldn't even be anything like it looks, okay? So worrying over how can I describe why it is that, or what's that information actually telling me? What am I missing here? There's something obviously that we're missing, right? If you've never worried about that, then finding something that actually gives coherent meaning to the question of what is the electron's mass, why does it have that magnitude of mass, and so on, wouldn't be all that exciting. But when you find something that actually gives the same value, that gives you a calculation and a geometric structure that allows you to actually make sense and reveal it, now it's a completely different game.
Okay.
The ones I'm looking to have come are the ones who have spent and want to spend their conscious energy and effort on the delightful chase, the biggest treasure hunt in reality there is.
Okay.
Consciousness treasure hunt. There are so many people in the past who have discovered things, real, amazing, beautiful things that make sense of things for you. So they've discovered a way of thinking, basically, right? Newton, Einstein, Euler. There's so many people all the way through math, right? You can sit around waiting for the math ideas or the big insights that all the people in the past have found to accidentally run into you, or you can be chasing them. I'm trying to find other people who see the value and want to jump on the train and say, ooh, this will change the world, let's do it.